Okay, so good morning everybody. Let's continue our discussion. Now I will just refer some of my material and I'll discuss some of the important concepts which you should understand by now. Okay, so the first thing first, we have seen the word count example in our previous sessions. Now let's try to get a little more clarity about how many mappers are created and all, right? So let's assume you have a file. Let's assume you have a file, file1.txt, okay, file2.txt, and file3.txt, okay. And let me assume the size of this file is 100 MB, okay, 1 KB, and 200 MB. So this is the data which you wanted to process, right? Now, when you stored this data in your SDFS, then this was stored, this was divided into only one block, okay? This was also divided into one block, okay? And this was divided into two blocks, okay? And let's assume we are working on a 5-node cluster. So I have 1, 2, 3, 4, 5. So let's assume we have a 5-node cluster here. So the data would be stored something like this, right? So the data are stored individually like this, and on those data we will have a replication factors, and they would be eventually replicated to 3, but let's not talk about that. So eventually we have got B1, B2, B3, B4. All right. Now, but I had only 3 files. Okay, I had only 3 files, right? And let's assume this file contains the same word count, so same words, right? And we are still working on the same word count example. Now, what I want to understand is, can you tell me, number one, how many mappers would be created? Okay, how many mappers would be created to process this job? So see, you are going to write a MapReduce program to solve this word count, right? So your jar file will have mapper, reducer, and driver. These are the 3 things which you are going to have, right? Mapper, reducer, and driver. And all these three, when you build, when you create this resources, when you create this file, and when you start running the program in a cluster, we'll see how to run that program in cluster later. But let's assume you have launched that program in cluster. Then what will happen is all this mapper will go here, right? Mapper, 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 and reducer also. The code will travel, as we know. Okay, the mapper and reducer code will travel, right? Okay, so the code has traveled in all these places. That's okay. Now, see, you have 4 blocks here, right? You have 4 blocks here, so 4 mapper object would be created. Okay, so what I'm trying to tell you is, for every block, 1 new mapper object will be created. It is also possible that this B3 and B4 are present here itself. It is also possible, right? So see, in the real time, you'll have a lot of files and one file will be divided into chunks, many chunks. For example, if I assume that there is a single file of 1 GB, and if you have a single file of 1 GB, then that would be divided into 8 blocks, is not it? If I assume 1 GB of one file, that would be divided into 8 blocks. And by that rule, definitely I know B1, B2, B3, B4, B5, then some blocks would be present here also, right? Maybe B6, B7, B8, and whatsoever. Okay. So even though you have 2 blocks stored on the same machine, okay, but still you will have 1 mapper object per block. Okay. So the rule of thumb is 1 mapper object per block, okay, not per node, okay, not per node. That is very important. So whenever you are given an input data, and if somebody asks you, can you tell me how many mapper object will be created, just see how many blocks would be created out of it. If I have a directory which contains let's say 200 files, and all these files are 1 KB files, right? Altogether, the size of the file, the directory is 200 KB, right? But since I have 200 files, 200 block will be created, and to process each block, one new mapper object would be created. Okay, how can you prove that? Okay, so proving this is very simple. All you need to do is you will just have to put a constructor in your mapper class. Okay, so see, that is the reason I tell the concept of Java is very, very important. And in our Java session, I've already told you what is the use of the constructor, right? Constructors are basically the blocks which gets automatically invoked during the object creation time. Okay, now by that rule, if suppose I have file 1, file 2, file 3, and if the file 3 is of 200 MB, and if we run our MapReduce job, right? If we run our MapReduce job, then just go and check your console, okay? And if you see the output from your mapper class constructor, right? What you can do is you can just say system.out.println constructor called from mapper class, right? And if you see that output 4 times, then it's clear that, okay, 4 objects were created, right? Because as we know, the constructor would be called only once during the object creation process. So if we are able to see them in our output, then we can be pretty sure that, okay, there were 3 files, but there were 4 blocks, and hence the constructor was created 4 times, right? So as I've told you, how many mapper object would be created? Mapper object would be created 1 per block. Okay, not 1 per file, right? So mapper object would be created once for every block. This is very, very important. Okay, now let me take up the next question. Okay, now the next question is, how many times your mapper map method would be called? We understood the map concept, right? Now the next question is, how many times your map method mapper dot map method, this map method would be called? And I've already told you in our previous discussion that this map method would be called once for every line by default. When I say by default, okay, so mark my word, whenever I say by default in any of the discussion, that means it can be customized. We will learn how to customize that in our advanced topics, but not immediately right now. So right now we are just talking about the simple word count problem, and how many times the mapper.map method would be called? 1 time for every line, right? So if this file has, say, 100 lines, if this file has, say, 200 lines, and if this file has, say, 1000 lines, altogether your map method would be executed 300 times, 1300 times, right? Because this would be called for every line. Okay, next, how many times reducer would be called? How many times your reduce method would be called? Always think about word count example. Your life will be easy, right? In word count example, when I had apple and ball, lot of apple and ball from my mapper, then it went to shuffle and sort group by, and finally we had only 2 groups, right? So this reducer would be called 1 time. Reduce method would be called 1 time per group. Reducer would be called 1 time per group. So if I have apple, ball, cat, dog, then my reducer would be called 4 times. Okay. Now let's talk about one real-time use case. Suppose your use case is, you are given 20 states data. Okay. You are given some files which contains the detail of 20 states, right? Now, and you want to do something with those data, and let's assume your mapper is going to emit state as a key, Andhra Pradesh as a key, Telangana as a key, Odisha as a key, Maharashtra as a key, right? So every state name would be emitted as a key. So that means finally in your group by, you'll have 20 different groups, right? And then there would be this method would be called 20 times. This reduce method would be called 20 times, right? Now there is a catch here. See, we know how many mapper object would be created. The mapper object would be created based on the number of blocks, right? And map method would be called based on the number of lines. So this depends on number of lines, right? And this depends on number of blocks. Now similarly, how many times, there are two things now. How many times reducer object will be created? That is one thing. And another thing is how many times reduce method would be called. So right now we are talking about the reduce method. Okay, we are talking about reduce method. So this reducer method would be called for n number of times, where n is nothing but the group, total number of group. If I have apple, ball, cat, dog, then 4 groups, and for each group one time reduce method would be called. Okay, but you may say, hey, how many times the reducer object can be created? Okay, now that can be customized. We will talk about that later, but it can be customized. By default 1. Okay, by default 1, but it can be customized. I can say, hey, I want to use 5 reducer to process my job. Possible. But altogether I'm saying that your reduce method would be called only those many times, where only those many times where you have the groups, right? So if you have 4 groups, 4 times. If you have 10 groups, then 10 times. So that is what is very, very important for us to understand. Okay, now let me quickly start on my VM so that I can show you some example of how many times the mapper objects are getting created and so on. Let me go back to VM again. We have to switch it on. I'll take up your questions once I'm done with this. Now we have seen map method, and in the map method what we saw, there was something called context object, right? So is this context object a shared object, right? Because it looks like that, right? Because whatever you are giving it to context, that eventually gets collected together, is not it? So it's very important for you to understand that for every block one mapper object gets created, and for each object there would be a brand new context object. Okay, for each object there would be a brand new context object. So context object would also be many. Okay, so we'll see that practically by putting some SOPs, and that's the best way we can look into it. Now let me talk about one more thing. So far the word count example, whatever we have executed, in that the input was present in SDFS, is not it? So we uploaded our data into SDFS, and in our driver program we wrote my input path would be from SDFS, and I will write my data back to SDFS, right? So my question is, can I stop reading the data from SDFS and can I just start reading the data from my local? Yes, you can do that. Again, output. Is it mandatory for me to write the data into SDFS, or can I write it into my local file system? Yes, you can write them into local file system. Okay, so if you have the data in your local file system, and if you don't want to move it to your SDFS, and if you want to process it using your Eclipse, the local file system itself, then you don't really have to point out your SDFS path. Okay, you can simply change your file path to pointing to local, and it will all be done, right? So that's what it is. So what I'm trying to tell you is, it's not necessary that you need to have the data in SDFS. Okay, now the question is, can I run my MapReduce program without starting my Hadoop cluster? Okay, so very important. I have a MapReduce program and I want to run that MapReduce program without starting my Hadoop. Is that possible? Yes. Okay, but make sure that in that case you are not reading the data or writing the data into SDFS, right? Because SDFS, if you have the data in SDFS, or if you want to write the data into SDFS, then definitely you need your Hadoop system up and running, right? But if you don't have your data in SDFS, then you really don't need to have your Hadoop up and running. Stop your Hadoop cluster and stop your Hadoop cluster, change your input and output path pointing to local, run your program, and you'll be surprised to see that Hadoop still works. And how it is working, it's all because of local mode. Okay, so Hadoop runs on modes. Okay, one such mode is local mode. We will talk about that mode in the coming days. But right now, what I'm saying is, by default, what Hadoop you are running, you are actually running it in a local mode. Okay, and in the local mode, you really don't need to have a cluster. They have capability to run it on your machine automatically. Okay, so we'll see that as well. Let me go back. Okay, now let me take a one more discussion. What is the default input and output formatters? See, in your Hadoop, whenever you write a MapReduce program, we all know that everything by default is key value pair, is not it? In Hadoop, the MapReduce program, whatever we have written, word count example or anything, you have to understand one thing, that the whole Hadoop MapReduce framework understands the concept of key value pair, right? So everything gets converted into key value pair, right? So as we have seen earlier, as we have discussed earlier, that the data would be converted into key and value pair, is not it? So even if you're giving a raw file, say file1.txt, and this file contains some data, right? This will be eventually converted into key value pair, right? Wherein the key would be like numbers 0, the length of the file is, let's say, 10, so 10, again the length of the line is, say, 10, 20, again let's say the length of the line is 15, 35, and so on, right? So 0 plus previous length, plus previous length, plus previous length, plus previous length, and so on. So this conversion from a raw file into a key value pair is done by text input format. Okay, so there is a predefined class called text input formatter. Okay, text input format, which will basically take care of converting your data into key value pair. Similarly, you have something called a text output format. Okay, so you have a class called text input format, you have a class called text output format, and these two formatters would basically help you to convert your data into key value pair, right? So that's what it is. So your data is present in a normal file, and you want to write the data, and you want to convert that data into key value pair. This will be taken care by this. Similarly, text output format can be used to write your final output. Okay, and by default, the final output would also be written in a key value pair, right? So Hadoop operates in the whole concept of key and value pair, right? So you have a key, you have the raw data, which will be converted into key value pair by text input formatter, as well as when you want to customize your formatting, you can use text input formatter to customize your format. Okay, so the class name is text input format and text output format. So we'll talk about this more in detail as we move on with the course, right? So as we know, by default, the text input format converts your data into long writable and text, right? And that is the reason when you get apple, ball, cat, they are converted into numbers. So these numbers are long writable, right? And the text, whatever string data you see, they are text. Is not it? Whereas in case of your text output format, this is of generic type, which means you have all the flexibility to get them converted into your desired format. Okay, if I talk about word count example, I basically have output like this, apple 10 or apple 5. So here my text input formatter is giving me the data in form of text and probably int writable. All right, guys. So let's see some practical. Okay. Now, as I've told you that the number of mappers, the number of mapper object that would be created totally depends on how many blocks are there, right? So in order to understand, what we'll do is we'll just go to our previous example, the word count with the needed jar, and let's go back to our mapper class. Okay. And here, let us try to add a constructor, right? So this is a Java class, is not it? And every Java class can have a constructor. So let's say my mapper, okay, and just say control space, and it will allow you to create a constructor like this. Okay, just say control space. Yeah, hit enter. Right now, here you can write something. So what I'm going to write is, I'm just going to write system.out.println sysout. Okay, and here let me say my mapper like this. Okay, just to tell that it is a constructor, or you can, yeah, you can just say my mapper constructor, anything. Okay, some information which will help us to understand how many times it actually got executed. Similarly, let me put it here as well. I'll put some SOPs here as well. So I'll say copy this, and I'll say my mapper dot map method. Okay, and I just want to also see how many times my map method is getting called, and let me also see what is this key. Okay, let us try to print this key, and let us try to print this value as well. So key plus, and let me put a separator like this. Let me put a separator like this. Done. Now similarly, let's go back to our reducer and let's create our constructor for reducer as well. My reducer, just write the class name and say control space and hit enter, right? And now here also you can just delete this and just say sysout. Okay, and here you write my reducer constructor, right? This is done. Next, now let's also put a key value pair. Let's also try to print here. I'll say sysout, and here you say my reducer dot reduce method. Okay, and I'll say word, and this iterable you'll have to print it while iterating, right? So the best way would be, let's print it here because it is anyways going to get iterated. So I'll say sysout, okay, and I'll say let me try to print iw.get. Okay, and before that what I can do is I can just say sysout okay, and let me say sysout and say like this, right? Okay, so we have just added few SOPs just to understand how does it even work, how many times what gets executed, right? Let's run the program and let's see what happens next. I'll go to my driver program, okay, and let's say run as Java application. Okay, as usual we are heavily relying on SDFS path, right? So let's go to terminal and just say start all.sh. Okay, Hadoop is up and running. So right, so before you start this program, make sure that your Hadoop is up and running. Just say JPS and check it out if your Hadoop is up and running. 1 2 3 4 5, right? Okay, this looks good. Let's try to run our driver program. All right, something happened and we are able to see there were some outputs. Let's go back and start counting them all together. So see, let me go down. My mapper constructor got called. Okay, it will be called 2 times because my input data has 2 input files. So you should see one more my mapper constructor somewhere down the line. Let's go down. Let's go down. Yes. So you're able to see my mapper constructor 2 times because you have 2 files and each file were so small that they were only 1 block. Is not it? And that's how it is. Okay, so let me go back to the mapper code. So this was executed 2 times, and that is just because you have 2 blocks. So what I can confirm from here is my mapper constructor will be called 1 time for each block, right? 1 time for each block. That means my mapper object would be created 2 times, right? 1 for each, because see, at the end of the day you are going to process them parallelly, right? In one machine, mapper object will be in one machine the mapper class would get executed. In another machine, mapper class will also get executed on some other processing 2 different blocks altogether, right? And it cannot be only one object, because when you have 2 machines, then it has to be 2 individual objects, is not it? Okay, then we started receiving this mymapper.map, right? So this is what we can see in our output as well. So just go here and see the output. Okay, now see here, mymapper.map. The first time it is 0 because it starts with 0. Now the second time it is 21, but let's understand how it is 21. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 slash n, right? 21. So that's what you got here, 21. Okay, now 22, so it is 21 here. Okay, now again let's count again. 1 2 3 4 slash n 5. 21 plus 5, 26. Okay, 26 again. 1 2 3 4 5. 26 plus 5, 31. And that's how your numbers are getting formed, right? So that's clear right now, right? How are you getting this key? These keys are basically generated by taking all the length of the previous file, okay, of the previous line and so on. All right, so I'm expecting this map method to be called for n number of times, where n is nothing but the total number of lines in my input file. So I'll go back to my DFS location and let me check my files, user, SD user, input, right? So this is file number 1 2 3, and this file number 2 1 2 3 4. So I have 3 and 4 7s, right? So you will have them 7 times. Okay, if you go back, your map method should be executed 7 times. 1 2 3 4, and you will see 3 in the next mapper object. Okay, you will see 3 in the next mapper object. 1 2 and 3, right? So see, in the next mapper object, if you see, the count again started from 0, is not it? So that's what I'm saying. Each individual map, when you start, will begin its count from 0 itself. Okay, next, reducer. How many times the reducer object would be created? Only 1 time in this case. We will see how to work with multiple reducers in the coming sessions. But right now, by default, only 1 reducer object would be created for this reducer class. Okay, so you will not see this 2 times. You will just see this only 1 time. But how many times your reduce method would be called? In this case, it will be called for 2 times, right? It will be called for 2 times. One for apple and another one is for ball. And that println, whatever we have written, here is just to show you that array kind of structure. Okay, so I've just removed /n from here, /n from here, so that it gets printed on the same line. And if I run this program again, then you should see them in a same line, right? So you should see them in a same line so that you can get a feeling of what exactly it is. Okay, so this will also be printed on the same line. So the reducer object was created only one time, and reduce method was called 2 times, right? So now what we will do is, let us try to see what if I don't have data in my SDFS and I want to read the data from my local file system. Do I even need to start my Hadoop cluster, right? So yeah, so what we'll do is we'll go back to we'll download this file first. Okay, so download from DFS, and where to keep, let me keep it in my desktop, and I'll say open. All right, so that should download that folder under our desktop. And let's go back to our desktop. We have word count underscore input, right? And let me say open in terminal. Okay, and let me say pwd, and here we go. We got the output. We got the input location, right? The local input location. Copy this, and then let's go back to Eclipse again. Okay, and we'll go back to our driver program, wherein I will remove this and I'll make it pointing to a local directory now. Okay, and let me just comment this, and let me also comment this, and I'll just say okay, and I'll just say output, right? So what we have done is we have commented out our SDFS path, and now we are saying, hey, I want to check if I can process this data from my local or not, right? So let's run this program. So once you run this program, I am expecting the data to be written into my desktop. All right, so if you see, now they are all on the same line. Okay, now you'll have to do a little more programming, guys, to get rid of this, but that's absolutely fine. That's okay. All right, now yeah, so now let's go back to our desktop, and you should see our output path is created here with one file part R 00000. And let me tell you what is the meaning of this part R here. Our job is a MapReduce job, which means we have executed our mapper. We've also executed our reducer in this process, and hence the file name would be part -R-000. Okay, if you disable your reducer, then the output would be part -M-00000. Okay, so it is possible to have only map only job. How? We will see that. Don't worry, right? We will have everything practically soon. Okay. Now let me do what? Let me delete this path. Okay, I'll say move to threads. Done. And then we'll also say stop all.sh. So I'm trying to stop my Hadoop cluster, and I'll try to run the program again, and let's see what happens. Will it work? Will it run or not without even starting Hadoop, right? So that's the interesting question of the day. Okay, so we have cleared our Hadoop, right? We have stopped our Hadoop services. JPS to confirm, nothing is running. Great. Let's go back and let's try to run this program. Okay, so I'll say run as Java application. Now, interestingly, the program is successful. Okay, and you're able to see all this output here. That's not it. You're able to see all this output here, and that means your Hadoop is you are able to run your program using Hadoop. And I have told you that it is just because of your local mode, right? So if you see, they were actually executed in the local mode. Okay, in local mode you really don't need your Hadoop services to be up and running. What are the different modes? We will see them in our coming days. Okay, all right, let's go back, and you see it has still created your part files. It's not it. Now what I'll do is I'll go back to this place, and I have word1.txt, I have word2.txt, copy and paste. Okay, I've created more copies. Okay, so altogether now I have 6 copies here. All right, altogether I have 6 files here. 6 files means 6 blocks. Let us run again, and you should see 6 times the mapper object would be created. Your mapper constructor would be would have six, total output from the mapper constructor would be 6, right? So let's go back here, and I would like to do one more change in my code here. I would also like to print Hashcode. Okay, I would also like to print Hashcode. What is a Hashcode, guys? Hashcode is basically one kind of number for an object. Not necessarily that would be unique. Hashcode can be same, but if I get different Hashcode, that means the objects are completely different. Okay, but I'm not saying that the Hashcode will be unique. I did not say that it is a unique number. Okay, I'm saying Hashcode is basically a number that represents an object. It is possible to have same Hashcode for multiple objects, but it is not possible to have different Hashcode for the same object. Each object will have one Hashcode. Okay. Now I just wanted to see if all those mappers whatever are getting created are the same mapper or they are new mapper objects, brand new mapper objects, right? Okay. Now let's go back and run our program again. So I'll say run as Java application. So we have 6 input files this time. All right, let's go back and check our mappers. Okay, so go a little down. Let me take it like this. Okay, so we start from here. So you have a mapper here, right? And let me say find. I think this is 2, this is 3, this is 4, this is 5, this is 6. Okay. Yeah, again we are back to the top. Okay, so they are 6. So wrapped search, no. Okay, now you see, I'll just say not found. Okay, and now let me go back. Okay, so we have 1, 2, 3, 4, 5, I think 6. Yeah, so we have altogether 6. Okay, so you have altogether 6 mapper constructor, which means for every file 1 block, and for each block 1 mapper object got created. Okay, so I hope this helps you to understand what exactly it is all about, right? So your mapper is running on each of these files individually. It's not parallelly and individually. And that's what the big data is all about, parallel computation, right? So the output of this mapper would be then shuffled. That means that would be brought together in a system, mixed together, and then grouped by, and then distributed to the reducer, right? So we will talk about that in the coming days.